Hi and welcome to this new video. I'm going to show you here a request that we had on how to get information from RVIZ and publish a camera from RVIZ in a ROStopic, and then using ROS Bridge publish this in a web page anywhere in the world so that people can see what you can see in RVIZ, both in simulation or in real robot, because as you know, RVIZ is just a way of visualizing robotic data, and it doesn't matter if it's a simulation or not. So here I'm showing you the results basically, which are, this is based on a template that was created by these guys from, have posted here the sources from WebViz. So essentially it's a stripped down version of this, but I think it's simpler because this way you just concentrate on having one camera or two cameras and just having a small feedback. I'll show you how this is done, and essentially what you're seeing here is two things. One, an RVIZ camera, which is this one. As you can see, we can see the robot, and then what the point cloud of this robot camera is seeing. And then on the other one is the camera, so the ROS camera, that it's also published. Yeah, but this is the raw data of the camera, and this is what we are seeing in RVIZ. How can we know it's RVIZ? Because if I go to my graphical tools where I have, let me just minimize myself here. As you can see here, we have RVIZ, and this is the part that it's seeing with the point clouds. If, for example, I say, hey, I want to see the TFs, then I go here, I click it. Here we can see the feedback, which is the camera, which is here, this camera that I'll also explain how this is done. We place a virtual camera inside RVIZ, and we say, hey, can you publish the data of that camera as it was a normal camera? And as you can see here, we have the TFs, and it's also published here, just because this is just showing you basically this camera stream. But here we can't see any TFs. Why? Because it's not the RVIZ, it's just the camera. Yeah, I just wanted to take a few minutes to explain this. And the reason why we need this is because RVIZ gives us a very powerful tool to show what's happening. This is very important in perception, in autonomous driving, in AI, all the things that the robot is perceiving, things that it's detecting. We can't see that in the sensors, in the raw sensors. We need the RVIZ, which visualizes. We can see the visualization of, I'm detecting this object, I'm following this path, this kind of stuff. Yeah. Okay, so how this was done. So let's go step by step. So they are basically, when I launch this, I do two things. Let me go to the instructions that I've made for you. As always, I'll leave the project in the video description, and also the Git so that you can download the code if you so desire. So we launched two things. We launched this RVIZ to WebPage, which essentially does three things: launch the simulation, generate this stream of RVIZ camera, which I'll show you, and then launch the ROS bridge in a special configuration so that it works in ROSDS, but it would be more or less the same in local computer or in your remote server, whatever. Yeah, this is one thing. The other one is that we are starting a web page, which is the one that we are seeing here. Yeah, so we do two things. So let's have a look at the code, how this was done, and clear up some doubts, I hope. So the first thing is we are launching the simulation. I won't go into detail, but essentially we are launching this big simulation which has our BoxBot robot and then a very simplified environment of a living room. Yeah, that's it. Then we have this, which is where the magic happens, which is this demo BoxBot. So let's have a look here. Here we do the following. First thing, we launch RVIZ with the configuration that we've saved, which is what we're seeing right here. And here we are putting some stuff that I'll explain later. Then here we are starting this camera publish. And we do two things. We publish the transform, which is where do I want this camera to be, and it's referred to what? And this is the position and orientation of the camera in RVIZ referred to chassis, which is the, if we go to here, the chassis is essentially the BoxBot, okay? The green box, that's the chassis frame. Yeah. And here we have the position, which is more or less 1 meter backwards in X, then 0 in Y, and 0.2 in Z, referred to the chassis axis. So let me show you that. Let's get the TFs a bit cleared up. There we go. So as you can see, it's the red is the X axis, Y is the green, and Z is the blue one. And then what we are positioning is this point here, the origin of this frame. So we go, what did I say, like -1 meter and 0.2. Yeah, more or less 1 meter and 0.2 up. Yeah, and then we set the orientation. In this case, we can do it with two methods, Euler angles and quaternions. I tried it with Euler and it doesn't work. Why? Because we have locking of the angles, and it just doesn't work, because you try to do a rotation in one and then a rotation in the other one, and it just flips the things around. That's the main reason why we use quaternions, because quaternions don't have this problem. Here I've left a very handy page, which is Quaternions Online, which is quite handy actually. I used it to position my camera. Essentially, I can apply any rotation that I want here, like for example 0, 0, and 0. And then we have the equivalent in quaternions. We can also visualize it here, and we can move it around and see more or less where we want to position a camera. After some trial and error, I'll just position the camera using this, which is more intuitive in Euler. So we basically here, I turned 90 degrees and 90 degrees just because the camera works that way. The camera is visualizing this. Let me just show you, because I think it's much more intuitive. If I add camera information and then I get the topic of the RVIZ camera, which is camera 2. There you go. So as you can see, we have the camera cone, and we can see where it is pointing. So you see that the Z-axis is the one that is like the face, the lens of the camera. Yeah. So using that, I positioned the camera. So it wasn't easy. So just that's the reason why I'm explaining this. But using this page, it totally was a game changer. It helped me a lot. I just put the Euler angles here and it gave me the quaternions, and that's it. I didn't have to care about anything else. Yeah. So that's one thing that I think it might give you problems. Then we have this, which I was amazed that it was quite complex if you don't know about camera settings, which normally you don't work with camera settings, you have them already done for you. So again, I give here a very handy page which gives a lot more information that I could give you right now in this video about how to generate the configuration of a camera based on the focal length and so on. And it has a very handy simulator here, which gives you a very good idea of what happens if I do a bigger focal length, a smaller one, if I change the skew and so on, sorry, the x0 and the y0, and also the skew. Okay, so all these parameters are the ones that we're using here in right here. So here's the focal length, and here I think it was the skew and so on, the x and the y. So let me get my notes for that. Yeah, so this first one was the focal length, x. Then we have the skew, which in this case is 0. We don't want any deformations on the image. Then this one is the x0. Then this one is focal length again, the y. And then this one is the y0. Okay. So based on this, you can deform and you can change the way that the camera works. So it's really important. And this node is the one that generates the images from RVIZ. Yeah, great. And then basically this one we just disable some plugins here, but not important there. Okay, so now with this you have a camera anywhere you want in RVIZ publishing this in a topic. Okay, first step done. Then the second one is, okay, now that I have my topic, now that now that we have the images, how do I put them in the web, in a web page? Here comes the third part of this launch, which is web server. And if we see here, we are doing two things. The first one is launching ROS Bridge, which is the one that essentially connects ROS topics with JavaScript. Okay, so if you have JavaScript and ROSlib here, and you have ROS here, ROS Bridge is the one that connects. Yeah. And then we have this, which I didn't understand at first why we had to do this. But the thing is, we have to compress images in order to have them in a web page. Otherwise, it won't work. And if it works, you'll have loads of data there which are not needed. And if we go to compress images, essentially it's a node that allows us to republish a topic on another one, and in this case we are compressing it. Yeah, and that's the thing that allows us to see what we're seeing here, which in this case we're seeing nothing because I left the information, camera information there. So at least it's working. Okay, so there we have it. So is that it? Yeah, more or less that's it. Now the only thing that remains is have a look at the Boxbot app, which is basically a strip-off version of the ones that I told you there. So here we have the index, and the only thing that I will comment on is the fact that in this version, because we are in ROSDS and we are in a system in the cloud and more complex, we have to use this address. So I forgot mentioning that to have the address that you have to set in the index HTML, you have to execute this address in any terminal, and then it will generate the corresponding address that you have to set in the file this way. Okay, again, if you are locally, you don't have to do this. You'll have to set the standard one, the localhost 9090. But if you're doing it on ROSDS or in a remote server or with sockets, or you'll have to do something similar to this. Also, it's really important, basically, the address and also the topic that of the camera. So if you go here, cam2, cam2, there we go. So we have to put, in this case, the camera information that will give us the feedback here that it's working or not, the camera. And then also we have it here, that we are declaring the ROStopic subscribers. In this case, we are declaring two. One, it's this RVIZ camera 2, which is the one that I explained you how to publish and so on. And the other one, it's a compressed image that it's published by default by our sensor, our depth sensor. So it's an RGB compressed image. So here we are changing the ports and the WebSockets. It's related to the system. By default, you wouldn't have to do this. It's just in the 9090 and that's it. But if you want it in a specific socket and in a different port because you have a system that uses that port, which is quite normal, then you have to change it here. And that's it. So the only thing that remains is if you go here and you launch the simulation with everything, and then we go to the Boxbot app and we execute Python 3 HTTP server and launch this, then I just have to do this command here, which is the one that gives us the address where we can go to get our web page. If we are doing it locally, again, it's just 0.0.0.0, and then 7000 because we set it here. Otherwise, it's this address that appears here in ROSDS, okay? And you should have something like this. So now for example, we can move the robot with our commands. Let me just have a look. There we go. So I'll move it around here and then I'll move it around there. And as you can see, we are having more or less real-time video streaming through the web of a camera from RVIZ, okay? So it's a bit Inception, this video, but it's really useful, and I've learned a lot about this kind of applications, especially the RVIZ camera, which it's really, really handy. And as you can see, there are some artifacts there, which probably are related to the rendering, but it works really, really well. And I'm impressed on how well it works. So before we go, remember that we are hosting the 4th ROS Developers Day, which is amazing. So the community is growing and growing. So we are super happy and super stoked for this. And just remember that the deadline is coming. So if you want to register and get your ticket, buy it now. We are having great speakers this year, amazing speakers actually. And last year I really enjoyed it. And it's a very good opportunity to learn hands-on experience from very talented roboticists and ROS developers. So just consider registering now, and you won't regret it, absolutely. And that's it. So thanks a lot. Give a like if you liked the video, subscribe if you haven't yet, and see you in the next video. Peace.